faithfully delivering value and interpreting great books worldwide. Hi, this is Sally here with Book Talks. Today, I'm going to interpret the book Unveiling the Modern British Industrial Revolution for you. The subtitle is A Global Deep Perspective on the First Industrial Revolution in Human History. Originating in 18th century Britain, it was a productivity revolution driven by new energy, coal, and mechanization replacing human labor. Revolution. Theoretical circles have long emphasized that technological changes drove societal prosperity. But this book reveals a different path. Britain's sustained high wages fueled the Industrial Revolution's outbreak. The author, Robert Allen, an Oxford economic history professor, compares energy prices and labor costs globally before the Industrial Revolution. He argues it could only start in Britain because only British capitalists had incentives to invest in new tech, replacing costly labor with mechanization. Innovations like steam engines, coke furnaces, and iron smelting needed massive coal initially. Luckily, Britain's cheap coal made these energy-intensive technologies spreadable. Next, I'll break it into three parts to uncover the logic behind the Industrial Revolution's outbreak. Part 1. Why could Britain's high wages persist? Part 2. How did Britain's coal industry rise? Part 3. How did coal ignite the Industrial Revolution? First, let's cover Part 1. Why could Britain's high wages persist? The Industrial Revolution erupted mid-18th century, but Britain's economic boom and wage growth began early 16th century, lasting over 200 years. How prosperous was Britain's economy then, and how high were the wages? First, the author presents data comparing construction workers' wages in East-West capitals from the 14th to 19th centuries. Regions fall into four categories. Delhi, India, had the lowest wages in silver, with daily pay fluctuating between 1 and 2 grams. The second category is Eurasia, like Austria, Vienna, and China, where Beijing's wages mostly hovered around 4 grams. As population grew, wages trended slowly downward. By the early 19th century, daily wages stabilized around 3 grams of silver, and population growth ceased. The third category is Amsterdam, where from the 16th to 17th centuries, wages accelerated with population growth. After daily wages reached 8 grams of silver, the growth leveled off over 200 years. The fourth category is London, UK, which initially grew at the same rate as Amsterdam. When Amsterdam stagnated, Britain surged ahead for another 200 years, hitting 18 grams of silver per day, a full doubling of wages. Other data gathered by the author also shows the same pattern. In the early 19th century, economic data across British society paints a vivid picture of the high-wage lifestyle. Here we'll cover three aspects. First, a lower share of income spent on essentials means people are wealthier, with more cash for extras, other non-essential goods. Given global dietary differences, the author listed a minimum living standard and calculated living costs as a percentage of wages. 68.
In early 18th century Britain, folks spent just a quarter of their income on basic needs.
But in most Eurasian countries, it jumped from half to nearly all, meaning people blew their whole paycheck just to eat. Even during the late 18th century grain price spike, an average worker could still live decently. A survey called The State of the Poor noted a gardener earning 30 pence a day could support his wife and 4 kids. The family could eat a quarter of a white loaf, about half a pound of meat, plus a bit of cream, beer, tea, and sugar daily. Second aspect is education spending. By studying signatures, most British workers could sign their names. This shows that from the 16th century, Brits generally got some schooling. Take that gardener, for instance. He shelled out 6 pence a week on his kids' education. Back in the late 15th century, English gentry couldn't even do basic math. Until the 16th century, literacy on the European continent was stuck in the Middle Ages. Third aspect is purchasing power across classes, also visible in inheritances. The author cites historians' work on changes in British wills from 1675 to 1725. Top-earning skilled workers could afford trendy imports like clocks, scrolls, paintings, and pottery. Oh. We now have a broad understanding of Britain's high-wage society on the eve of the Industrial Revolution. This raises two questions. First, why were British wages so high? Second, why could these high wages be sustained? Let's start with the first question. Why were British wages so high? The main reason was that woolen textile exports brought immense wealth to Britain. Back in the Middle Ages, the wool industry center was in Italy's Mediterranean region, fostering prosperous cities like Venice and Florence. But Britain could only export raw materials, wool, and low-end heavy broadcloths. So, how did the wool trade hub shift to Britain? First, British wool became superior, and this traces back to the Black Death. In 1347, the Black Death swept Europe, cutting the population by 25 million, about one-third. Italy was hardest hit, with Florence losing 80% of its people to the plague. Britain wasn't spared either, and the Black Death had an unexpected result. After the plague, Europe's population rebounded quickly, but Britain's recovered slowly. Land once for crops turned to pastures, especially in central England, where fertile soil grew nutrient-rich grass. Sheep fed on this grass grew longer wool, perfect for worsted fabric production. Second, Britain hiked the tax rate on wool exports. If traders exported raw wool, the government took one-third of the price in tax, forcing them to process it into worsted cloth domestically before export. Finally, colonialism and mercantilism gained ground. While European nations all set up chartered companies to compete for markets in India and China, they imposed trade protections on colonies, allowing only home merchants. Britain began overseas colonial activities in the 17th century, opening foreign markets for British worsted cloth. The second question, why could high wages last? From population and wage trends, as cities grew and labor specialized, societal efficiency improved, boosting international competitiveness. And the bottleneck limiting urban population growth lies in agricultural productivity. When agricultural productivity is low, more urban population drives up food prices, pushing people back to rural areas. At that time, major countries and capital regions followed this pattern, but only Britain and the Netherlands diverged. Why? It's because these two countries were the first to complete the agricultural revolution. Taking Britain as an example, the agricultural revolution roughly went through three stages. The first stage was a surge in wool demand, which boosted incentives for land reclamation. Throughout the 18th century, 8 million acres of wasteland were converted to pastures, equaling a quarter of England's territory. In northern England, driven by profits, even small stones were cleared from pastures, enhancing grass growth. The second stage was an increase in wheat yield per acre. As urban wages grew, meat consumption rose, so farmers expanded planting of legumes, like peas and beans, to feed more livestock, as these provide protein. This also led to an unexpected result. Legumes have strong nitrogen-fixing abilities, absorbing nitrogen from the air and enriching the soil. Though slow after centuries of accumulation, wheat yields improved significantly, aided by factors like better seed selection. By the early 18th century, wheat yield per acre increased by nearly 50%, supporting a larger urban population. The third stage was the emergence of the enclosure movement in rural areas. Large-scale farming emerged. If higher wheat yields were unintentional, then large farms represented a deliberate improvement. For crop yields, large plots were used by landowners for agricultural experiments, such as domesticating new crops and crop rotation trials. From the early 18th century, after 20 years of experiments, landowners found optimal rotation methods, while small farmers competed by buying abandoned lands and collaborating to create experimental fields, racing to boost yields. Post-agricultural revolution, Britain had stable food prices, urban population grew further, providing ample labor for the wool industry and gaining a competitive edge, allowing high wages to persist. That concludes the reasons for Britain's sustained high wages. Now let's move to part two. How did Britain's coal industry rise? Before the Industrial Revolution, coal, like other fuels, was first used for heating. Before the Middle Ages, nearly all nations used charcoal for heating. Since impurities were removed during charcoal production, burning it at home didn't release harmful gases like CO2 or SO2. And as population grew, charcoal's drawbacks became apparent. Compared to Europe, Britain had scarce forests, and charcoal supply was limited by wood's slow growth cycle. Around 1700, pre-industrial revolution, Britain's timber could only provide heat equivalent to 2 million tons of coal, but energy needs required 5 million tons. Far short. Thus, wood prices soared, with London's urbanization up 50% in the 16th century and doubling in the early 17th, mirroring wage hikes. Meanwhile, coal, a known fuel, wasn't widely used domestically, limited to industries like lime burning and blacksmithing, with stable prices. Coal produced heavy smoke when burned, and smokeless coal hadn't yet emerged. Medieval British homes had low hearths unsuitable for cold heating. So for coal to replace charcoal, smoke emission had to be solved first. Fortunately, conditions aligned for coal industrialization in Britain for three reasons. First, soaring charcoal prices made new energy exploration profitable. In the 1650s, the charcoal-coal price gap jumped from 2 times to 4 times, covering new chimney design costs. London industries like pottery kilns and bakeries would redesign buildings if coal proved economical. Second, London's boom created new buildings for energy experiments. From the 16th to 17th centuries, London expanded rapidly. New buildings rose, creating a market where engineers learned and competed. When someone designed a better chimney, peers quickly copied and improved, something impossible in coal mining regions. Coal mining areas were located in central, western, and northeastern England, with sparse populations and few new buildings. Third, canals solved long-distance transportation issues. Central western England and Wales produced half of total coal output, but inland transport costs were high. Transporting coal to London required extensive canal construction, involving private land acquisition. The 1688 Glorious Revolution, Britain established parliamentary supremacy, greatly improving administrative efficiency. Canals were rapidly built, lowering coal transport costs and securing London's supply. In contrast, France overprotected private property, hindering public infrastructure. For example, an irrigation project in Provence. Halted by landowners' lawsuits, France wouldn't match British efficiency until the French Revolution over a century later. Meanwhile, the Netherlands, once equally prosperous, lacked coal industry development, missing key Industrial Revolution conditions. 3 reasons. First, peat supplemented charcoal after price hikes, peat being coal's early form, abundant in wetlands. Situated in lowland marshes, the Netherlands had rich peat deposits that became primary energy when charcoal couldn't support population growth. Second, peat stabilized charcoal prices but couldn't sustain further urbanization. With peat evenly distributed nationwide, prices varied little. Merchants had no incentive to centralize supply to Amsterdam, limiting city growth. Britain differed. Newcastle coal cost half London's price, making sea transport profitable. Third, inland coal transport was costly. Amsterdam sat at the Rhine estuary near German coal fields like Ruhr. The Netherlands could have mirrored Britain's coal industry, but Rhine tariffs from fragmented states eliminated peat's competitive edge. By the time Britain mined Newcastle extensively, Amsterdam couldn't develop its coal industry. Because coal from Newcastle cost almost the same when shipped by sea to London and Amsterdam. Thus, only Britain possessed the necessary conditions for the Industrial Revolution: high wages and cheap coal. Finally, we explore part 3. How did coal ignite the Industrial Revolution? By the early 18th century, coal was widely used for home heating. Britons began adapting it for steam engine fuel and iron smelting, but faced technical bottlenecks in two areas. First issue: early steam engines consumed excessive coal, limiting their applications. The steam engine's origins trace back to 1655. In the 17th century, German Otto von Guericke proved atmospheric pressure could perform work through vacuum cylinder experiments. Building on this, Thomas Newcomen created the first practical steam engine for mine drainage in 1712, using cold water to condense steam and create vacuum. But early steam engines were coal hogs, consuming about 45 pounds per horsepower hour. This high energy consumption restricted their usage.
Fortunately, pithead coal was cheap, making steam-powered drainage cost-effective.
By late 18th century, steam drainage spread across European mines, but broader industrial use required reduced coal consumption. So how is steam engine coal consumption reduced? First, James Watt improved the steam engine. Starting in 1763, he repaired Newcomen engines, and through years of observation, he discovered Newcomen engines wasted energy. Cooling the cylinder with water to condense steam also chilled the cylinder itself. Reheating the cylinder for new steam wasted enormous energy. Watt wondered, could steam be diverted to a separate chamber for condensation, keeping the main cylinder hot? Following this idea, Watt created the separate condenser in 1765, halving coal consumption. Now, steam engines could power other industries, like metal mining in Cornwall, far from coal regions, where Watt's efficient design became viable. In the following years, Watt redesigned the valve system, allowing steam to enter the cylinder alternately from both ends, so the piston could power movement in both directions. And then, in 1800, Richard Trevithick created the high-pressure steam engine using pressurized steam from a high-pressure boiler. High-pressure steam engines had two advantages. First, steam pressure alone could drive pistons, using less coal.
Second, they delivered powerful thrust, capable of moving heavier loads.
After innovations like pneumatic controls, balanced valves, and compound cylinders, coal use dropped to 1 pound per horsepower hour, just 145 of early Newcomen engines. With this power and efficiency, steam engines spread to railways and shipping, finally expanding coal's use beyond mining. Now, the second challenge, coal as iron smelting fuel, faced technical hurdles. Steel output was a key industrial revolution metric, defining a nation's industrialization level. Mass steel production was essential for mechanization. Traditional smelting used charcoal, whose carbon monoxide and hydrogen reduced iron ore to pig iron. But Britain's scarce forests forced coal to replace charcoal for mass production. Coal's flaw was high sulfur content, making pig iron unrefinable into wrought iron. In 1712, Abraham Darby solved this with coke smelting, using purified coal, coke, where impurities were removed.
But coke smelting initially yielded only half of charcoal's output.
So how is coke smelting output improved? First, after 20-plus years of tinkering, Darby designed a reverberatory furnace in 1735 that blew more air, finally matching charcoal's yield. Second, technologies reinforced each other. Early blast furnaces relied on water power, stalling during dry seasons. Some solved this by adding horse-drawn pumps to recycle water from downstream. And by 1742, the company switched to Newcomen steam engines for pumping. Seasonal impacts were eliminated. Similarly, early ironworks installed wooden rails for material transport between departments. As pig iron output rose, ironworks replaced wooden rails with durable iron tracks. Later, lifting machinery reduced labor needs and slashed costs in iron smelting. After a century of improvements, hot blast and waste heat recovery technologies boosted furnace temperatures while cutting coal use. By 1850, a single furnace produced 4,600 tons yearly. Coke smelting finally surpassed charcoal output. In contrast, coke smelting spread later in Europe due to high initial coal consumption, France's abundant forests kept charcoal affordable, delaying adoption until Britain lowered costs a century later. Improved coal efficiency and exploding steel output relentlessly powered the Industrial Revolution. First, productivity skyrocketed as mechanization spread across industries. By the 1830s, spinning machinery cut cotton yarn prices to a quarter of early Industrial Revolution levels. Second, it revolutionized transportation. Early iron rails were limited to internal transport in mines and ironworks. Trevithick's early 1800s steam locomotive sparked nationwide rail networks, connecting Britons. And finally, industrialization reshaped the world. Ocean fleets evolved from sail to steam, freeing shipping from wind dependence. Britain built the world's largest fleet, flooding global markets with affordable goods. With that, we conclude Unveiling the Modern British Industrial Revolution. Let's briefly recap the book's key insights. The core thesis: the first industrial revolution, defined by coal, iron, and mechanization, could only erupt in high-wage, cheap coal Britain. Part 1 on Britain. We explained Britain's sustained high wages resulted from agricultural revolutions in Britain and the Netherlands, supporting more artisans and dominating Western Europe's wool trade. Well, Part 2 covered how Britain's scarce forests versus abundant coal, combined with London's growth, drove coal adoption. This made it the primary heating fuel for residents. London attracted more people, enabling greater labor specialization and higher wages. Compared to the Netherlands, Amsterdam's wages rose further. Part 3 showed how surging coal demand spurred steam engine inventions for mine drainage. Through continuous improvements, steam engines gradually spread to other industries. Crucial iron smelting benefited from coal refining and coke oven upgrades, with industries mutually driving down energy consumption. Coal and iron's widespread use profoundly transformed society. Britain's Industrial Revolution marked humanity's greatest leap forward. Later industrializing nations followed this template. Starting with textiles, then infrastructure and machinery, they spread industrialization throughout society. But newer industrializers tapped fresh energy sources: oil, nuclear, now renewables. While competition boosted efficiency, Britain's pioneering rise reveals this truth: those who harness new energy efficiently gain competitive advantages. All right, that concludes Unveiling the Modern British Industrial Revolution. Find show notes below, and we'll see you next time.